glad to be here, and I'm going to tell you about Quantum Software Lab that was launched only 2 weeks ago. Some of you were there with us. If not, you have a chance to hear about what is this beast. It's a national lab. It is an academic lab. Is going to be an in-between place. It's not a company. It's not just academic, and I'm hoping to share with you a little bit about what we're trying to do, and it's very similar to what we have been hearing. We are all here because we're all excited. We really believe there is lots of Lego pieces around to revolutionize our problem solving. All of the other speakers are already pitching about how we're going about it, but we believe, we in part of this National Quantum Technology Program, that there's all these different actors in the place. Of course, in order to find these quantum resources that are going to do the magic, as we heard, we need to do discovery. We need to do a lot of science to be able to discover them. We need to look at the technology to do the implementation of them, and in order to really deploy them, as we're hearing about all of the partner, as well as use cases. That's why we are here trying to understand who are our users. So we are obsessed about all these pieces, and in the UK that I'm here supposed to present, the National Quantum Technology Program, we have all these elements have been already active over the last decade of the various investment that has been in the national program. We have Quantum Computing Simulation Hub, which is leading by the many scientists. We have the NQCC, which was launched 2 years ago with dedicated national test bed in order to deploy and accelerate in deployment between prototyping from academic to industry, as well as Innovate UK, which has been leading this use case discovery. So what is our Quantum Software Lab supposed to be doing is like, we're going to be now obsessed about putting these Lego pieces together. We want to build manual construction, like everybody's trying to do, but the way that we're trying to do it in the Quantum Software Lab, we're trying to be a bit of a glue. Okay, I always say these wonderful sentences that some of you who have kids know that it takes a village to raise them. And about quantum application, I guess we're all agreeing that it takes also the entire ecosystem from all the actors to come together to really deliver this useful quantum application. And in particular, I want to pitch you a little bit in what is this environment, because it's not a company, and exactly why we have decided to set it up, this acceleration lab, if you wish. So our local ecosystem is the wonderful University of Edinburgh, which has been ranked over and over as one of the top places for the computer science. We're coming from the Computer Science School of Informatics, so we need the training, we need all those fantastic students to actually driving it, and we are also part of the innovation team. There has this huge culture of acceleration, already base centers that we are sitting on top of. But more importantly, in order to deliver this quantum application, we have been building this village. For the last decade, we have been trying to putting all the various expertise together. And today we have a 30+ member who are actively working. And that's why we put forward to create this lab after that we have that village. So, and in the wider context, I'm talking about quantum ecosystem. So, of course, even the Quantum Software Lab, which is trying to be an engine and bring the glue of all of this thing together, has been working, being both in CNRS as well as the UK. Already we have the collaboration with Sorbonne University and INRIA in place to make sure that this is remain good old Europe that is working together, as well as making sure that the use cases, all the companies that are around in the landscape, wherever they are part of this picture, and very importantly, the national lab as a trusted node, whether it's Alan Turing Institute in Machine Learning, whether it's NPL for Physical Laboratory, EPCC High Performance Computing. Essentially, it's like one big soup that we believe we need to bring everybody together to finally, nail it down. Where is this quantum application? So what is our approach? Our approach, if you wish, is a very much reverse approach. Is B2Q, but it's okay to present it at Q2B for time being, But it's really what we believe, and what I passionately believe, is that we're trying to do a bit of a reverse pitch, as I've been saying in so many different contexts. We believe it is the time that we can bring the end-user pain point and trying to understand it, but it's not to right away to turn it to a bunch of code and running it. It's actually this end-user pain point need to go through this user journey that we're hearing from everybody, but now we're going to do it in an academic domain. That's what I want to push it. We are doing to be startup culture, but doing it in academic. And that's even harder than building quantum computer. Bringing 5 professors to work together is not a trivial thing, but we have been doing that, and we're trying to make sure we go through this cycle of understanding what is the use case, and when we have that use case, what is exactly the mathematical problem that use case is defining it. And now that becomes a very interesting research problem that comes from outside rather than from our head to be pushed to go back to the industry. That's why I'm saying this is a B to Q. And of course, at the end of the day, we need to take it to the design center and trying to do it as much as possible, benchmarking, and go through this loop, and hopefully go back. Because we're not a company, because we don't have a particular hardware in mind, because we don't have a particular software in mind, because we don't have a VC to trying to bring a return on investment, we can bring all of our feasibility study to the community to try say, well, I think the hardware should do like this, well, I believe this application goes there. So that's the dream in short. So let me go through it, but of course I would have not been able to launch such a thing if it wasn't because of all the other colleagues and senior people which are going to lead it. This is not going to be a one-woman show. It's a really bunch of people that have come together from a very different background, colleague from formal method, from HPC, from high-performance computing, from cybersecurity, from the noise analysis, and we put all of these things together and trying to see if we can speak one language and trying to work together. So, what are we trying to do? Our use case development. This is the beginning of our journey, which we're trying to bring people like you or your 2Quantum, as I said, with more classical business people to trying that. What's the big deal? What are your bottleneck? Where do you going? And this is very, very difficult. You know, we have been trying to do this over and over with our team, with the student, in order to get an engaged industry who's happy to sit down, to share their problem, as well as helping us as a domain expert try to do this reverse pitch is a difficult job. That's why we need to be part of ecosystem. NQCC National Quantum Computing have launched this program of Spark, which is precisely acting as this trusted node. So hopefully people can come and tell them and trying to achieve and understand what are the problems that needs to be actually go through this cycle. So we have already launched similar event like AIM Day in Edinburgh, which was again also 2 weeks ago, and it was quite interesting to understand the gap between what people outside they want and how we can translate into a mathematical problem that a PhD student need to spend the next 3 years trying to crack it down. So this is just an advertisement for Spark program. If you right away want to get engaged, please go ahead. This is a National Laboratory of Quantum Computing Center in UK that is dedicated in not only access to quantum resources, but as well as doing the translation between what is the pain point towards the use cases that can come as an input for our problem. So, for example, you know, everybody has talked about these are the different problem types, whether simulation, machine learning, optimization, cryptography, etc., etc. We know all of these, and we're very happy that NQCC will do that job, because then out of that, let's take finance that we are all very excited about, or maybe, then we taking this sort of different sector, which could be, okay, numerical analysis, optimization, machine learning, and cryptography. But for me, it's not just like, okay, picking up those buzzwords and trying to get money out of it. It's just more exactly going through this, you know, systematization of the knowledge of exactly, okay, what are those problems? Which problems sit in each one of them? And once we have that one, then we have this input that comes to our lab, that comes to our software lab, that, okay, we understand this category, whether it's finance, material science, or anything else, you know, science for the sake of science, as Feynman was envisioning it. But the more important thing that we like to understand is what's the pain point. Pain point is not always just about the speed. It could be accuracy, it could be the cost of production, it could be integrity, it could be energy cost. And I think here is where we academics love to hear something from our end user, that what are those pain points that we're trying to solve? Because each one of them can have its own tailor-made solution. Let's say that we are successful, we have hundreds of these use cases. So now, how do we do this in order to make sure, as the other speaker were also advocating, that it should be a bit more kind of, you know, systematic way of doing it? Because it's not like every time we need to rediscover the path of how do we do this discovery. And for us, what we are taking, we're taking this whole machinery that, it exists in the formal method laboratory foundation of computer science in the School of Informatics has been pioneering it. It's sort of both bottom-up and top-to-bottom. Again, we're doing it in scientific, academic environment in the sense that we want to translate those requirements, those pain points, to mathematical property that now speaks the language as the research question. And at the same time, we want to create this sort of platform and template of the common, because we all know that quantum Fourier transfer will pop in so many places. We know that this particular pattern recognition is popping in so many places, and at some point we want to abstract it so we can understand when can we match it together. And maybe as a solution we will create, of course, the Kaggle with the Q, and we have this open source platform that everybody can pitch their pain point, everybody can put their current solution, and it will be our job trying to see at the abstract level how we can get this thing together. Fantastic. So we get our translation, and finally, we're back in the normal day-to-day office work that, okay, we know the template, we know the requirement, we know the pain point. Let's put our wonderful student and teams and researchers and our brain together to match it. And in order to answer which part of this use case can benefit from the quantum and in which way. And again, here already you need to analyze it. Okay, I have lots of templates that I can go through them. Maybe these fall under the same thing. But I also need to make sure that these requirements are matching. So this template problem matching is where, again, we can work openly with all hardware, with all software, with all end user, because there is enough pain point that we can all try to target it together. Once we successfully putting all of this in together, the solution, the outcome, hopefully would be new and optimized quantum algorithm that we can also push back to the translation center as a new template to be sitting there, as open library sources, etc., that you want to see. It's also very interesting, this sort of use case-specific hardware requirement. Already Shane was advertising that it's so important that sometimes we can go back to our hardware partners and we want exactly this sort of connectivity, this sort of native gate, that sort of a specific one, because it's addressing my pain point. And of course, we need to put the ticket of the price and how important it is, but that's the job of the community and end user. We're just delivering all of this requirement and hopefully informing the development of the hardware and technology how to go, as well as benchmarking. Like everybody talks about benchmarking. I know it's a wonderful word, and we put so many things under it. And in order to everybody have their benchmark favorite for their platform, but we want to do benchmark, as I will discuss in a second, how it is full-scale benchmarking and agnostic to the hardware. Okay, so that's the part, and then it comes to the, if you like, the implementation center. And in the implementation center, here's come again, if we really want to take advantage of the current existing hardware, they are not universal. It might take a long time. We have fault-tolerant, universal, error-correcting, but that doesn't mean we should stop doing what we're doing and waiting for that D-Day to arrive. In fact, we need to start figuring out which resources is required quantum, which resources needs classical. And in order to adjust that, we don't need to reinvent the wheel. We know that this full stack, there is a lot of things in between, as we always say, and there is lots of classical control and classical architecture design that can help us, whether we go with the distributed fashion model that we have been pioneering in our team, whether we go to the HPC integration, but we need to really, again, my message of, we're not going to do it alone. We need to bring those expertise, and we are very lucky to working with the ICSA, which is the Institute for Computer Architecture, and they are becoming quantized. They're trying to understand that what can they bring to the community, trying to add that. And finally, putting all these pieces together, we have this vision that, forever I've been pitching to the whole world that we need to have secure, verifiable, distributed quantum computing that allow us, we all sit down on it and trying to address both scalability, integrity, and privacy at the same time. So that's one of the future blueprint that we're trying to develop with their pieces of the puzzle. And the most important part when we come to the end of our journey is, as one of my colleagues wants to say, to be quantum or not to quantum. That's exactly where we have to address. And we are academic. We can do that. We don't have any agenda. We just want to get promotion to the next level, which is not a big deal. So indeed, we want to be as honest as possible and as a trusted node that is really trying to do this benchmarking. Could it be because we need to bring error noise mitigation there? No problem. We need to bring benchmarking against classical HPC. We need to look at the comparison, we look at the verification, we look at the testing, and all of these things will be again part of our Kaggle, part of this tailor-made. And the reason we're bringing these people together to talk, because if you just come with machine learning, you don't put the correct error mitigation, you don't do the verification, you're missing piece of the puzzle. So we were trying to address that gap in the center. And then the answer will be quantum advantage. Maybe can be achieved now, which is fantastic, and many of the people are doing it. That is very likely that is very much technology-driven and innovation-driven. But I think the biggest contribution that our lab or academic lab will do in order to say that how and when it can be achieved is not today, but we should be able to go back to the ecosystem saying what is missing to make sure that we are ready to deliver that quantum advantage. Or there is no advantage. No shame. We can exactly also demonstrate when there is no advantage, forget about this sector, let's go to the next use cases. So that's the goal. And just to give you a little bit very quickly saying it, like this is what we have been doing in order to putting the pieces together. One example of this sort of dream that I'm hoping that in the next few months and in all the future Q2B that you will hear about our quantum software lab we can demonstrate is this sort of discovery. So we started with the synthetic data, where the pain point is both privacy and accuracy of data. It's not about the speed, which is interesting. The standard chartered brought it forward. This was part of an Innovate UK project. In the translation, we worked both with Sorbonne University and the University of Edinburgh to understand that actually there's two subroutines that you need to do. The usual beloved machine learning for the, if you wish, the generative model. Actually, Brian, one of the pioneers of this work, is somewhere in here, as well as differential privacy, which is adding the privacy part of it together. Then that was the model that actually we went to the hardware. In that project, we were working with Rigetti, trying to benchmarking over the hardware, as well as adding the software layer that need to go in order to add the privacy in its come. So you see, this is the ecosystem that we build, and now we're believing, okay, privacy preserving quantum machine learning using this particular QLAN architecture of the very cloud, which is happened to be my own company, is one of the area that we can go back and really pitch it to the ecosystem. Please go ahead to build. But this story that I'm showing you, it comes out of so many other research. So during this process, our chairman, Jonas Landman, has been leading this work to actually say that, is it really the case that we get quantum advantage? And, before necessarily aiming it, actually, we ended up to show a large family of the variational quantum eigensolver that don't provide quantum advantage. There is using Fourier transform methodology that you can approximate them. No problem. We understood which class, and we actually identify where and which type of Hamiltonian might can give an application. The fact that we go through this methodology actually starts saying, okay, we need to look at this expressivity of this Fourier transform model and trying to give us a framework that next time that I want to design a variational quantum eigensolver, what type of Hamiltonian should I put there? What sort of requirement do I need to go back to tell to Pascal to build it in order to ensure that we have quantum advantage rather than being in the domain of classical simulatability. And the bottleneck that comes out of it becomes exactly data encoding. You need to look at the native gate, right, to see that can I do a particular data encoding. This is actually one of the work of Jordanis from QCware that we have pioneered, and we're following it up exactly, tailor-made this data encoding. So what I'm trying to bother you with is that every time you ask that question, there is tons of research that needs to go through it. When it comes actually, it reiterated another research that should we actually forget about adiabatic, and in fact one of my colleagues adopted how to do adiabatic quantum computation using variational circuit to actually reduce the number of the parameter. Here, carry on. Then we go back to the question of security privacy that I said that we need to put on top of this machine learning for the synthetic data. And it turned out that we needed to reinvent the entire quantum differential privacy framework to understand what's the notion of the noise. Do we get it better than classical? How do we redesign it? And it turned out also we need to do it the secure multi-party computing. Is it really the model that we can do it? So what I'm trying to say is that it's only, error mitigation also. It's only not only takes the ecosystem, it takes a lot of research to actually deliver useful quantum computing. So don't try do it at home without scientists. That's my message for all of you. And the biggest asset that we have on Quantum Software Lab is really the student and the research and these young people who are enthusiastic. they are actually, compared to my generation, they are very happy about use case. So the business people bring your pain point because they are happy to do the research that is related to them. And we would have not launched this lab if it wasn't because of those people. So just feel fishing with this. We don't have a booth, it's too expensive. Just come talk to me directly. We are ready to start collaborating with you. We are ready to address the gap in the ecosystem and work and assist with everybody in this journey. Thank you very much.